Okay, so we're going to go ahead and get started. It's 4 o'clock. So this is Regex101, and hopefully you're in the right place. So we're going to jump right in. Who here has been to a website where you try to put in a phone number, they have a specific format they want you to put it in? Annoying, right? You get it wrong a couple of times, or a website, and when you do it wrong, they somehow seem to know that the format that you put in was incorrect in the phone number or email address or website and things like that. And so how do they do that, right? Do they have a list of every single possible phone number out there in the world, and if you happen to put in one that is valid, then they accept it as valid? That's not practical, that's not possible. The way that we in computer programming do it is we use regular expressions. So I'm going to talk about what regular expressions are. Regular expressions, or regex for short, is a way of creating patterns, and we try to match text against these patterns to see if certain text match certain patterns, right? So regular expressions is part of almost every computer programming language out there, in C++, and JavaScript, and Java, and Perl, PHP. All of them have regular expressions built in. So the syntax of regular expressions is the same no matter what language you go into. There's a few different flavors depending on the language you're in, but for the most part, the main syntax is the same. So everything that we learned today will apply in Java as well as in C++ and JavaScript. I use JavaScript, and so I'm less familiar with that, but it'll work everywhere. The syntax is basically the same. So the way this course is going to go is I'm going to, with you guys, we're going to build a regular expression or a pattern that will match phone numbers. And as we're doing it, we're going to learn more and more about the different syntax and the different meta sequences and all these different symbols and what they mean in regular expressions. Once we do that, then we're going to go on to the more advanced how to build a regular expression to match websites, and then we'll ask questions, and that's it. So as we're doing these examples, you're going to learn a lot about different symbols and what they mean in regular expressions. So I'm going to go ahead and start. I use a website called Regex101.com. It's fantastic. So if you were to go to Regex101.com, you'll see what we're looking at here. And the reason why I tell you this is we're going to be using this here. You don't have to take feverish notes because everything is on Regex101. They have this quick reference guide here that explains what every single one of the characters mean, what all the nuances are. You can click and find out more information, things like that. So don't worry about taking too good of notes. It's all available online. I don't work for Regex101. I just think it's a great website. So we're going to go ahead and get started by trying to come up with a regular expression or a pattern to match all phone numbers against. Okay? So let's just take a sample phone number here. Okay, so I'm going to write my very first pattern, my first regular expression, and we're going to see if it matches how to match this phone number. So I'm going to write 801-225-0971. And what do you know? I wrote a pattern that matched this text perfectly. So the way that I know that it matches that is highlighted in blue, and that's how regular expressions, Regex101 shows that it's a match. And let me explain to you what the computer is doing underneath, and we're going to get more advanced here, okay? So what it is saying is, given this text or string, look for an 8 that is immediately followed by a 0, immediately followed by a 1, immediately followed by a hyphen, immediately followed by a 2, followed by a 2, followed by a 5, followed by a hyphen, 0971. Okay? I say that sounds dumb, but we're going to be using that same way of thinking throughout this course. So this is a terrible regular expression, right? It only works if they insert exactly this phone number. So we need to come up with a more generic pattern. Because what if they had the same phone number, but they wrote it with periods instead of with hyphens? Well, this second thing doesn't match, the first one does. So how do we write a pattern that will match both hyphens and periods? And this is the first thing that we're going to learn is how to create a set. Okay? So a set is contained inside square brackets, and what it means is I can start typing in characters here, and the character that comes after the 1 has to match one of the characters that I put in this set. So it has to be either an A or an S or a D or an F, J, K, L. Does that make sense? So this is called a set. We define a set between square brackets. And for what I want to do today, I'm going to define a set where it has two things in it, a hyphen and a period. So what this is now looking for is for an 8 followed by a 0 followed by a 1 followed by either a hyphen or a period. That's what this is doing. Followed by a 2250971. So if I were to put a hyphen and period here as well, we now have a pattern that will match both of these phone numbers. Does anybody have any questions about how to create a set? Great. Now what if they put spaces instead of periods? Anybody take a guess of how we could handle this case? Let's put a space inside of our set. That's a possible valid value that we could have in that spot. And now this is saying look for an 8 followed by a 0 followed by 1 followed by either a hyphen, period, or space. Followed by 225. Anyway, so on and so forth. But what if their phone number is, all of a sudden this doesn't work, right? Somebody has a new phone number and our pattern doesn't work. So we need to get rid of, we need to figure out a way to be able to get rid of the specific digits that we have here in our pattern and genericize this pattern more to be able to allow any digit. Well, that's pretty easy, just using sets. So if I were to put, if I were to say that the character could be a 0 or a 1, 2, 3, 4, 5, 6, 7, 8, 9, you'll see here that it matches every one of these digits. Because what this is saying is look for something in the set 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And all of these numbers fit that pattern. Okay? So if I wanted to, I could do 3 of these followed by our little hyphen space period, or yeah, thing, followed by 3 of these, followed by 4 of these. And now we have a regular expression that will match phone numbers, at least the ones that we have here. It'll match, if we put another one, it'll match that. So this is pretty good. But this is really complicated and there's an easier way to write this. It turns out that in between square brackets you can actually put ranges, not just specific characters. So if I wanted to, I could say look for anything, for any digit between 0 and 9. And that, instead of having to type up 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, we can put a range. Okay? So I could write the same thing, doing 3 of these, 3 of these, and you get the picture, right? So that's a little bit better. And I like that. But we use the set 0 through 9 very often in computer programming. So they've come up with a shortcut. Instead of having to type in square bracket 0 through 9 and square bracket every time, they have a shortcut. And the shortcut is /d. What the slash means, the slash is a funny thing in regular expressions. The thing that comes after it, if it's a special thing in regular expressions, which the /d is something special, then this doesn't just mean the character d, it means match something that is the set of 0 through 9. So that's what the slash means. Also, if something does mean something special in regular expressions, putting a slash in front of it makes it not special. So we're going to be using both, it kind of negates the thing after it. So if I were to put /d/d/d, and then this thing, and then do 2 of these, and then /d/d/d, now we have a much easier to read way to look for phone numbers, right? And if I hover over this, Regex101 will say that /d is the same thing as saying a set from 0 to 9. Does that make sense? Any questions about this so far? Okay, so a little bit of vocabulary. The square brackets are sets. The /d is what's called a meta sequence. And that's what we have so far. So let's do one more thing. What if they were all cool and they put in a phone number like that? Our regular expression pattern doesn't match that. So let me show you how we would make a regular expression to match that. So we need to look for an opening parenthesis. Okay? It just so happens that parentheses do mean something special in regular expressions. So the thing that I just explained, where if something does mean something special, to make it not special, put a slash in front of it. So I'm going to put a slash, open parentheses, And that means just look for a plain old literal open parentheses, okay? And then I'm going to put a slash closing parentheses, and then oh, excuse me, I put it in the wrong place, that's why. And sweet. This matches this now, but it doesn't match anything else up above because it is always looking for a opening parentheses followed by 3 digits followed by closing parentheses, and none of these do, right? So we need some sort of way in regular expressions to be able to say that this open parentheses is optional. So this is where I'm going to explain something in regular expressions called quantifiers, okay? I'm going to open up a new tab, and then we're going to go back to the previous tab to finish this out. So there are 4 ways to define quantifiers in regular expressions, and I'm going to go over all of them. So say we have a string that is ABCD, and I'm going to type in a pattern here that matches that perfect. What do you know? The first quantifier means quantity, right? We're going to define how much we are looking of a specific item. So if I put a question mark here, here's what this does. It says, the question mark says the thing right in front of me, whatever it is optional. It can be there or it can't be there. Another way of describing that in computer talk is there has to be 0 or 1 of the thing right in front of me, okay? So this pattern still matches the string because what it's looking for is for an A and a B followed by a C, or the C could not be there. It just so happens that the C's here followed by a D. If you get rid of the C, the pattern will still work, okay? It's just making the C optional. If I put 2 C's here, it doesn't work because it's looking for a C optionally followed by a D, and we have ABC followed by a C followed by a D. So this doesn't work. There's another quantifier that will work with this, and it is the star. What the star means is the thing before me, there can be 0 to infinity amounts of it. Okay? So if there are 17 C's, it'll work. If there is 0 C's, it'll work. So saying 0 to infinity of the thing right in front of me, that's what the star means, okay? Now what the plus means is 1 to infinity. So it's like the star, except for the star is 0 to infinity, the plus sign means 1 to infinity. So it is saying there has to at least be 1, but there could be multiple of the thing right in front of me. So if I put C, 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 it'll still work. If I get rid of all the C's, it won't. It has to at least have 1. So, yes?
Can you stack quantifiers like do like a question mark?
You can. It does something different that you're not expecting. So we won't go over that. It does something weird. I just found out this year. All right. So far the 3 we have is question marks means 0, 1. Star means 0 to infinity. The plus sign means 1 to infinity. There's one last one which allows us to define a specific number, a specific quantity, and that's using curly braces. So if I put curly braces here, I can put a digit in here, and what this 3 means is this thing right before me, there has to be 3 of them, okay? So this doesn't match, that matches, okay? In between the curly braces, you can also put a second number, meaning there has to be 3 to 5 of these, right? So this will match, this will match, this will match, this won't, because there's 6 now, right? So you can say 3 to 5 of the thing right in front of me. And if you leave out the last digit and just have a comma, what it means is 3 or more. Okay? Kind of cool. So I can have lots of C's, but if I have less than 3, it won't match. So the 4 quantifiers are question mark, which means 0, 1, star, which means 0 to infinity, plus, which means 1 to infinity, and then curly braces, which mean the specific quantity number. So now I'm going to flip back here, and I want the open parentheses to be optional. So I'm going to put a question mark there. Okay, and what this question mark is saying is the thing right before me, which is the escaped open parentheses. It can be there or cannot be there. And I'm going to put a question mark right here after the closing parentheses, and boom, we have a regular expression now that will match all of these. Does that make sense? Any questions about that? And now knowing what we know about quantifiers, we can clean this up a little bit. Instead of having 3/D's next to each other, I can say 3 of these, and 3 of these, and 4 of these. Does that make sense? So we just came up with a pattern that will match a fair number of phone numbers. There could be some nuances and some weird things. If they put a space there, this is going to break it, right? And we could keep coming up with all of these crazy conditions. And but as a general rule, this regular expression, which is just a pattern, will work to match phone numbers. Before going on, I'm going to show you real quick how I would write this in JavaScript. It's going to be the same thing in PHP. It's going to be the same thing everywhere. In JavaScript, this is really small. In JavaScript, you define regular expressions between 2 forward slashes, okay? The thing in between it is the regular expression. So if I were to put this in between the 2 forward slashes, okay? And this is an object in JavaScript, so I'm going to test it against a certain string. And I'm going to say 801.225.0971, and let's see if it passes the test, and it does. If I were to put something that didn't match that, like this, it'll return false. So you can see here the syntax that we're using for regular expressions, it works in every language, almost the same. Little differences here and there. So that's how you create a regular expression for a phone number. If there's no questions, I'm going to go on to the next more complicated thing, which is websites. Great. All right. So how do we make this part here? Match a website or an email address or something like that. A little bit trickier. We're going to give us a clean slate. And I'm going to try to create a pattern that will match google.com. Okay? The easiest way I could write a pattern to match google.com is by writing google.com. This is looking for G followed by an O followed by an O, L. But wait, look. This period has a blue box around it, which Regex101 is telling us that means something special. So if I highlight over it, what it is saying is that the period matches any character as long as it is not a line terminator. What's a line terminator? If you look here, we say google.com. Now watch. If I push return, right there, you can't see it, but there's a line terminator. Okay? That's what a line terminator means, the start of a new line. So a period will match anything except for a line terminator. So I could actually write a pattern that goes ... And this will match the pattern perfectly. But the rule in regular expressions is be as specific as possible. Don't be as generic as possible. And using a bunch of dots is like using just a big star wildcard thing, right? And so it's not very good. So we're going to write something better. But in order for me to say literally I'm looking for a period, instead of what this is saying is look for any character after an E followed by C. It just so happens that this period is not a line terminator, so it falls underneath the pattern and it works. But I want to literally mean a period, so I'm going to make the special character not special by putting a slash in front of it. And now it's looking for a literal period. Make sense? Okay, so what if Google.com? Whoa! What if Google.com had a Google.net out there? Our pattern no longer works. So I'm going to explain a new thing. Before I told you that parentheses meant something special in regular expressions, and they do. They create a group. Okay. So when I put parentheses around this com, it did nothing. It still matches this, and it didn't match this. But what it did was it created a group with com in it. And one of the things you can do inside of groups is you can use the OR operator inside of regular expressions, which is a single bar. Single bar is located on the top right hand of your keyboard. A single bar, and now I can say match com or match net, and that works. And if I have another one that is .org, I can say or org. Or I can say .biz, and I can add biz here. Okay, so we could write a regular expression that has every single possible letter combination that a website could use for the ending here. The ending is called a TLD, or top level domain. And I don't know what the exact rules are. They've changed a little bit, but it is big. I can't remember what the rules are, so let's make up rules. Let's say that every single website has to end with a dot something that is 2 characters long to, let's say, 9 characters long, right? Because they can be I don't know if you guys have seen endings like .green, .me, .visual, all these different things. So it can be anything. So we need to write something where we don't have to list every single possibility. We need to write a pattern. So we can do that with what we've already learned, which is with sets. I can say A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z, and put 3 of these, and it'll match all of those. Okay? A little bit tedious, but that's totally a possibility. Or if we're a little bit smarter and we've learned something about quantifiers, we can say 3 of them. But like I said, I don't know what the exact rules are, but let's say that the rules are there has to at least be 2 and there can be 9 things after the period. Okay? So we now have, this is a lot cleaner. But just like you can create ranges for integers inside of square brackets, you can also create ranges for alphabetical characters. So instead of listing out A through Z, I'm going to literally type A through Z. And that'll work. And what this is looking for is any lowercase character A through Z. So if I want to also get uppercase characters, I go capital A through capital Z. And because this is a set, it's saying find anything here, also anything in this range. Okay? So this is now allowing us to look for any alphabetical character, 2 to 9 of them after a period. Make sense? Anybody have questions about that? Okay. So I'm going to, and that also matches a 2 character thing, right? I'm going to come up with another example though. What if they said Google inbox.me? Or let's just do Google Photos, all one word, okay? So we need to get rid of this Google here and just rely on alphabetical characters. So rather than typing Google, I can do this whole, I can do a range and say that there has to be at least 1 to infinity, but instead of typing that, we know that is the same thing as putting a plus sign there, right? So now this is looking for any alphabetical character, 1 to infinity of them, followed by a period, followed by 2 to 9 alphabetical characters. And I should put A to Z up here too, so that we're case insensitive, as the internet is. That'll work until we have Google -index/.me. This doesn't match. This does match this part of it because it's looking for alphabetical characters followed by this. It won't match the beginning because this has a hyphen in it. Okay, so I can add the hyphen to the set, and we're hunky dory. This will work until we have googlemaps.com. How do we get the underscore in there? Well, we just add another thing to our set, and we add the underscore. And it could also include numbers, right? So if we have a 3 there, we can just say look for a 0 through 9. So this works. This is great. There's another shortcut here that I want to explain. It so happens that in computer programming we use the set, this particular set very often where we are looking for A through Z, or capital A through Z, or 0 through 9, or the underscore. Wait, this is a very common data set that we're looking for. So they came up with a special character for it, and it's /W. What does the /W stand for? Word. It's a word character, okay? And if I hover over it, it says this is the same thing as writing A through Z, capital A through Z, 0 through 9, and underscore. So it's just a shortcut. It stands for word character. And this hyphen is not a word character, only underscore is. So I'm going to add it to my set here, and we've got it all back again. Any questions about this? Yes.
I might be wrong on this, but with domain names, I think you have to start with a letter. So wouldn't you find that differently, saying the first letter has to be, the first character has to be, then add in all that other stuff?
Sure. I didn't actually know that rule. I don't know the rules about domains, so I'm just totally making this up. But if we wanted that to be, we could do A through Z, or capital A through Z, and there has to be 1 of them, followed by 0 to infinity amount of any other word character, right? Great point. And if people know more about what a website is actually supposed to look like, please speak up. That's great. Any other questions? Okay, so what if, though, they put HTTP, google.com? Well, we got a situation here. Because I can type HTTP, Now, it just turns out forward slashes are special characters in regular expressions. So to get rid of them, to make them not special, I'm going to backslash both of them to say just look for normal, literal forward slashes. Okay. This matches this down here perfectly now, but it doesn't match any of the rest of these because they don't start with HTTP. So how do we handle that? Well, if I were to put a question mark right here, what is this saying? It is saying the thing right before me, there can be 0 or 1 of them. The thing right before the question mark is the forward slash. So it's making this slash right here optional. I can either have it or I can't. I want to make this whole thing optional. How do we do that in regular expressions? We're going to create a group using parentheses. I'm going to put parentheses around this and all of this. And now what the question mark says is 0 or 1 of the things immediately before me. The thing immediately before me is this whole group. So it's making the whole group optional. Okay? Does that make sense? And what if it says HTTPS, as Google is? How do we make the S optional? Well, I put S and a question mark. And this is totally okay. We have a question mark that is surrounded by another question mark. And that's totally valid and fine in regular expressions. So we have here a decent regular expression or regex to match websites. There's a lot of other things we'd have to take into account, subdomains and different things like that. But for the purpose of this class, this is a decent regular expression to match a website. Any questions about this? Okay. So then, the next thing that I wanted to explain is regular expressions. So they're useful for validating, right? It's useful to say that this is not a website or this is a phone number. That's awesome and that's useful. If you have a programming job, great. You can use this in that one scenario where you want to validate. The thing where I think regular expressions gain a lot of power is that they are very commonly used for find and replace stuff. Okay, so I use this all the time for normal, everyday, non-computer programming related tasks. So let me show you an example. So my mom sends me a list of email addresses separated by commas and spaces, right? And let's say it's a list of 1,000 long. She's like, oh, I really wish that they were each on their own line. You know what I mean? And you're like, well, instead of going through and manually deleting this and putting it in its own line, I can come up with a regular expression that will do that for us. So in regular expressions, there's a way to substitute. I'm going to open up the substitution box here in Regex101. And right now, I'm looking for nothing, replacing with nothing. It's spitting out the exact value here. So I'm going to very simply help my mom out. And I'm going to say, I'm going to look for a comma followed by a space. And I'm going to replace it with a new line. Okay? What this just did was it found all the commas and spaces, commas followed by spaces, and it put them in new lines. /n means new line. If you didn't know that, that's a regular expression thing. It's also a computer thing. But so immediately, in just a couple of clicks, I have a great pattern that'll match that. She's happy, I'm happy, we're all great. Any questions about this simple example of replace? I'll show you how we do this in JavaScript. You make regular expressions by slashes. I'm going to, oh wait, oops. I'm going to look for commas followed by spaces, and then after the last slash, I can put what I want to replace it with, which is a new line, and I'm going to execute this against. Oh, never mind. Sorry, I was thinking PHP for a second. It is, I do this dot replace, and then I can put my regular expression, which is this, and I'm going to look for all of them, and it'll spit out. Oh, I didn't replace it with a new line. Sorry. Now it'll spell them all out in a new line. Okay, so this is transportable to every language out there. Great. So that's a very simple regular expression, and it's not very exciting. Let's come up with another one. So let's say that this is kind of annoying. We see this all the time in the headers, right? You have a list of email addresses, and your mom, I don't know why I'm using an example of my mom, but she wants all of these in a new line, and she wants them to have like some text in front of it. So I'm going to show you another way of doing a regex using this. So I'm going to look for quotation marks, and in between the quotation marks, I'm going to look for any alphabetical character, or it could be a hyphen, or it could be an underscore. And we're smart, and we realize that we could write this easier by just doing /w with a hyphen, since that wasn't included in that set. And it could also be a @ symbol, and it can also be a literal period. And there's going to be 1 to infinity amount of them, followed by quotations. Okay, so this is now matching quotations with everything inside of it. But I only care about the things that are actually inside of the quotes. So what I'm going to do is I'm going to put the thing that is inside of the quotes in a parenthesis. Now, what has happened right now? Nothing. This looks the exact same as it did before without the parentheses. But what the parentheses do is they create what is called a group. Okay, and groups are very, very lucky for us to have when we're doing replacements, because this group is the very first group I've defined. If I have another parentheses, this parentheses is now the second group. This is the first group. This is the second group. Not too difficult to follow. So with this first group, with the substitution, I can access what was inside of the first group by doing $1. 1 meaning the first group. Okay. If I had a second one, then I could access that by doing $2. But we only care about the first group. So what this is saying is we only care about the thing in between the parentheses, not the thing outside. I say in parentheses. We only care about things inside of the quotes, not the quotes themselves. And so I'm replacing this whole thing with just what's inside of the capture group, which is this -1. And now I can put a new line here. I want to get rid of this comma space. And now I can say something like email. And see, now we can do all sorts of fancy things with it. We can even say, for some reason, I also wanted it in parentheses, so I'm going to put the $1 there as well. This matches all of them except for the bottom one. And why is that? Well, there's not a comma followed by a space after this. So it doesn't match our pattern. So I'm going to make the comma and the space optional, and now it matches all of them. Does that make sense? So that's great. Let me see if there's anything else I wanted to explain about that. Nope, that's it for this replace. I'm going to do one more. Okay, I'm going to copy this, and this is kind of cool. This is kind of cool. I'm excited. So a set is things inside of parentheses followed by anything that you want in the set. There's a way to say, look for any character not in this set. Okay, how do I negate it? And the way you do that is you start off the set with a caret symbol. That means find any character that is not in this set. Okay. So what I'm going to do here is I'm going to say look for any character. Okay, let me explain what I'm trying to do in the first place. I want this string to be put underneath here, but I want to capitalize the first character of every single one of the words there, so I can make the names be in title case. Okay. So I'm going to look for. I'm trying to figure out how to get all the spaces and then get this first character after it. So I'm going to say. Look for anything that is not an alphabetical character. Why did I put square braces instead of square braces? Look for anything that is not an alphabetical character. It's going to match the comma, the space, and everything that's not alphabetical character. Okay? Look for any of those things followed by an alphabetical character. I think it's auto-completing things for me. There we go. So now we're catching the thing right before the alphabetical character and the alphabetical character itself. Okay? And what I'm going to do is I'm going to put parentheses around this one. It didn't change the pattern. I'm going to put parentheses around this one. It didn't change the pattern, but it created two capture groups, this first one and the second one. Now, if I were to write $1 and $2, we get the exact same thing back. Okay? Because we're just saying put what was in here and what was in here back down here. Okay? Or replace them, sorry. So that's not exciting. But in regular expressions, there is a command that is /u, which says capitalize the next thing after me, which is this number 2 here. So now we see that Goodman was capitalized, Michael Jackson was capitalized, Karl Malone, Steve Jobs, Bill Gates. Everything except for Clint was capitalized because this expression was looking for something that was not an alphabetical followed by an alphabetical character, and there's nothing before the C. Okay? So the way that I can handle that is I'm going to teach you one more special character, and it is the /B. This stands for word boundary. If you were to highlight over it, it would show you this complicated thing that if you want to write it longer and see what it really means. But basically, everything that's followed by a space or beginning of a line or end of a line, that creates a word boundary. So I'm looking for any word boundary followed by a single character, and I want to uppercase that second character. And that's pretty cool. You're starting to see that we have some seriously cool stuff that we can do with regular expressions. If I wanted to put these all in a new line, I would say look for anything that is not a comma. There could be a lot of them followed by a comma, and I'm going to put this in its own capture group. Okay, so I'm going to say $3 and then a new line, and it keeps them all in caps because this /u is saying everything following me. So that's a bit of a mistake. But anyway, I'm just showing you more and more regular expressions and examples. There's a lot of powerful things we can do. So I use this all the time for, I recently got married and we got a big list of email addresses, so I had to do this to get my email addresses in a readable way, right? You can also use, there's several other, I use it in my code all the time. I'm a React developer, so we have, we can define attributes. So this is how you would define an attribute in HTML. And sometimes I want to go through and replace the strings with actual variables. And so I can write regular, in almost every text editor, there is the ability to use regular expressions. In VS Code, if you click right here, it says use regular expressions. And I can look for anything that is not a quotation mark, and a few of them, and I want to replace it with, instead of that, I want to replace it with curly braces and what was inside it in the first place, like here. And if I click replace, it did exactly what I asked it for. And so I use this all the time to refactor code too. It's very helpful because you can scan your whole project and do a regular expression replacement of your entire project and look for stuff. So this is what I had. Yes? Is it, sorry, a command line way of doing that? No. You can definitely use it in the command line. There's tools like the very common one that grep. Grep can use regular expressions, if you're familiar with that, are you? Yeah, there's other ways to do it too. I don't do it, so I'm not an expert at it, but definitely possible. Any other questions? Like I said, this is it, and so you can either go early or you can ask a question. Any other questions? Great, so in recap, regular expressions are patterns. They match against text. We can use them very powerfully to do validations as well as to do search and replaces, and I highly recommend them. And the last question.
So say I'm new to a company, I'm looking through their code and I can find a super complicated regular expression. How would you go about figuring out what it does in an efficient and quick way?
Great, yeah, great question. So honestly, if I were you, I would put their regular expression and paste it right here, and then I can go through every single one. Look, it has this explanation of what exactly the computer is looking for. It found the first captured group because /B matches all of this stuff, the second group, the third group, and fourth group, and it's pretty easy way. Also, if you want to look up the things manually, like say, I didn't know what the /S meant, then you can put it here and it says any non-white space character. For every single special character, there's also an anti of that. So /B is any word boundary. Any non-word boundary is capital B. So you just capitalize the character. Any /W is any word character. Capital W is any non-word character. Okay, it's just a way to negate it. So I would post in Regex101.com. I think it's a great website. Does that help? All right. Nothing else? Yes.
Aren't there name groups like carrot less than greater than?
Yes.
So you just name it, name another group, and you can add.
Yes. So you're exactly right. You can start doing crazy things with the group. You can even say, I actually don't care about what's in this group and make a non-caption group. You can name groups. You can repeat groups. There's a lot of things. The problem once you start going down that road is that that works in some languages, but not every language supports that. There's things called look-ahead expressions, which use groups, but not every language supports that. So once you start going down that trail, it's awesome if your language supports it. Not all of them do. A way to discover if they do or don't is just by Googling it. There's a Regex.info, I think, and it explains what's available in every language. So you start getting a little bit of the flavored language differences there, and that's not so fun, but that's a great way. Anything else? Okay, well, thanks for coming. Go home early, have fun, and thank you very much.